Good morning.
Good morning.
Oh, I thought you were going to give us your catchphrase.
Last off.
Oh, I thought the other one.
Oh, trigonometric.
Yay. Welcome back. I know it feels like it's been forever since.
It has.
Hi. Take them off. Anyway, we're doing lecture right now. Are you going to grab this off the video later? All right, then go ahead and grab that seat. Focus on what you're doing so that way you may not be interrupting anyone near you, okay? All right, thank you very much. If you want to leave room to put KWLs for the current assignments that you've done, now's the chance for you to do it. Decide how many assignments you're going to do KWLs for and leave that much space for yourself. KWLs now are no longer checked as part of notebook check. I'm no longer looking into them to see that you're doing them. They're for you and your use only. So if you do not feel like you need to have a what I knew, what I worked hard on, and what I learned from, then you do not have to have them. Yes, sir. Hopefully not. All right, please note the lesson code for today. Shh, shh, shh. Put the phone up, please.
Is it another short?
Okay, you're taking. Do you want paper? All right.
Miss, just to confirm, the last notes that we had was the quadrilateral.
Yes, the quadrilaterals were indeed the last notes that we took.
There was nothing posted online.
Yeah, there's nothing new. You had this one lecture here, the part 2, but that was it.
Okay.
So if you haven't gotten the part 2, it's here photocopied for you, or it's available online, listed quadrilaterals part 2. All right, I do want you to make note of this lesson code that says that we're back in chapter 6, in fact, the first part of chapter 6. The book wanted us to show it before we did quadrilaterals. I was worried it would confuse you. And it doesn't really, it leads better into the next unit if it's here. So we're going to bounce back for a second before moving forward. But before we talk about our actual polygon angle sums, we need to take a moment and think about the different polygon angle sums that we already know, such as the triangle angle sum. What is the triangle angle sum? What do you get when you add up all the angles in a triangle?
180.
Yeah, 180.
Oh, I was going to say perimeter.
What about the quadrilateral angle sum?
You get the area.
Go back a page.
360. Right?
360, yeah. All right. Before this lesson is over, you will have a formula to be able to calculate the interior angle sum of any number-sided polygon. We don't have that formula yet. We're going to have it today. But the thing that you need to know is that these formulas are only for convex polygons. What's a convex polygon? Yeah, flip back.
All interior angles are less than 180.
Beautiful. She flipped back a page, the start of the quadrilateral unit. We talked about convex polygons. And we reminded ourselves that those interior angles are all less than 180 degrees. So something that looks like this, not something that looks like that. Okay? We need to take a moment and deal with the naming convention of our polygons, because we're pretty soon going to get to the point where these polygons have a lot of sides, and we need to be able to find a way to talk about what polygon we're looking at in reference to the number of sides that we see. Okay?
How long are these notes?
So the first section of this is going to be the number of sides, and then we're going to deal with the name of the polygon. Now, from a purely theory standpoint, this is people sitting around thinking deep thoughts about things.
Are we going to have like a
A little table.
Like a house?
Yeah, like a little table. we could theoretically have a one-sided polygon.
A line?
Yeah, it looks like just a line, but I don't like. I can't even imagine it. Okay, I have no idea what this shape looks like. I have no idea what we might even call it. It's out there on Google. I know it is.
Miss, wouldn't it be considered a rectangle?
No, because a rectangle has 4 distinct sides. 1, 2, 3. Yeah, like how do I get back to here from here without changing direct? Like I don't even know. But yes, it's some serious math magic going on. But theoretically, this thing exists and you can talk about it. We're just not going to because it's way too weird. Same thing with the 2-sided polygon. Because, I mean, what would that 1, 2? I don't even. Like, we're not, okay? We're going to start our discussions with 3.
Triangle.
Yeah, triangle. Now I'm going to put a little bit of space between these word parts so that you can see which word parts are doing the counting for us. Try is the word part that's doing the counting for us. And the triangle, out of all of our polygon names, is the rebel. He's the only one that his name has a word part for angle as opposed to side. He's a rebel and a crazy person. Okay. What about number of sides? What's the name for our 4-sided polygon? That's very specific kind.
Quadrilateral.
Yeah, quadrilateral is the more general.
Are we gonna put an example to the side or?
You want to draw one off to the side?
Yeah.
Okay, let's go ahead and do that. So here's our triangle. Here's our quadrilateral. Again, you can make yours look like anything you want. Mine kind of looks a little bit like a rectangle. You can make it look, I don't know, like a rhombus if you wanted to. A rhombus. What about 5 sides?
Pentagon.
A pentagon. Now, there's a difference in our naming convention here. Notice how we go from quadrilateral to pentagon.
It's gone.
He's gone. What happened here is way back when we were first starting maths, not you and I, but like us as humans in general, in the Western traditions, this is stuff coming from ancient Greece and ancient Rome, it's where our mathematics began. The lateral is a carryover from the Roman Latin language, which is why it sounds very similar to our Spanish lado, for side. Because ancient Latin is kind of the mom, great-great-great-grandmom of Spanish, okay? Whereas this word part gon, meaning side, comes from Greece, completely different language, not related to Latin. And so it doesn't translate to us as directly as lateral does. Make sense?
Yes.
Okay, so pentagon, pent being the Grecian word for 5. What about 6-sided?
Hexagon.
Hexagon. Again, we've got this kind of Grecian prefix here. 6-sided is a little more challenging for me to draw. 1, 2, 3, 4, 5, 6. It's like 2 trapezoids stuck together on their long sides. That's how I think about it. All right, what about 7? That's 10, yeah. Heptagon, yeah. It actually has 2 different ways to name it. You can name it the heptagon, or you can name it the septagon.
That's the one I heard.
Yeah, that's the one you've
I've
heard.
never heard that.
I heard
That's
that.
the one.
You've never heard septagon?
Yeah.
You've heard
Heptagon.
sept before to reference 7. You just don't know it, and we're about to get into it. So hold on to that. We'll come back to this. So hang on to this word part right here. All right, let's draw. How do you draw this? I don't know, 7 sides and make it convex. So 1, 2, 3, 4, 5. 6, 7. Okay, really? I don't. Not happy. All right, 8.
Heptagon.
Octagon. Yeah, the stop sign. So this one should be easier for me to draw. 1, 2, 3, 4, 5, 6, 7, 8.
That was easy for you?
Because easier for me to think through.
Pentagon.
Not what?
Nine.
Nonagon.
Oh, no, I was close.
Okay, you're not wrong with ninagon, but I'll come back to the reason why in a bit. And you had said 10 was decagon?
Yes, ma'am.
Okay. Can I not draw the rest of these?
No, you have
No,
to.
you
You have
don't
to.
have to.
you have
I don't have to?
Because I
have to
didn't
do-
draw.
Yeah,
I
you
see
have
you
to.
do. Oh.
I
You
didn't
have
draw a
to.
heptagon because I don't know
1,
what that
2,
You have to.
3, 4,
It's like you got
5,
2 points
6,
and-
7, 8, 9.
Oh,
Title, yeah.
is. Too good.
Just outside with.
Better than nothing.
Yeah, right? Okay, 10. 1, 2, 3, 4, 5,
Nope.
6, 7, 8, 9, 10. Oh, man. I give up on life. No.
Okay. I'm doing it.
All right. Take a look at these word parts for 7, for 8, for 9, and for 10. Are those familiar? I'll email. Thank you, sir. Are they familiar from anywhere? What do they kind of look like?
The 7 looks
look like
like
stop signs.
septimo.
Like where?
Like septimo, like seven.
Septimo?
Like when you're saying Spanish.
Oh, like when you're doing the counting
Yeah.
cardinals. Okay.
What are you guys? They have a gun.
Yeah, man, this bones a question.
So this first word part, sept, oct, non, dec.
They're numbers and hexagon. It's gonna have 6 of them.
Away from numbers, where else does it look familiar from?
From chemistry?
From chemistry? Okay.
Yeah.
You got it from there? Okay.
Movie.
What about months of the year?
Oh, September, October.
September, October, November, December.
Oh,
But what month of the year is September?
9.
7? I don't know my English.
September.
It's 9. You're exactly right, but this thing says it should be 7.
I don't know my months in order. Oh, maybe back then we
October.
didn't have-
October's which month? The 10th, but this thing says it's 8. Like, what happened? We get to blame the Romans.
That's racist.
She asked why. Here's why.
It's a racist.
There used to be only 10 months of the year. Month 1, month 2, month 3, month 4, month 5, month sept, month oct, month non,
Wait, they
month
didn't have
dec. Yeah, 6 is clearly not important. Sorry, I wanted to get to the punchline. I skipped 6. But then along came this emperor, said, I am the metal, super awesome boss. I want a month. And they're like, dude, you can't just rename a month. Like, you can't. Everyone's going to freak out. He goes, no, dude, I don't want to rename a month. I want my own month. Just make a new one.
Wow.
They're like, well, okay, I guess, Mr. Julius Caesar, we'll make a month for you. And we ended up with July.
Oh,
Wait, which one was the
Julius.
month?
July.
Then which one is the other one that we didn't?
June.
And so July, coming somewhere before September, September got shifted down.
January.
So it stopped being 7 and became 8. And then along came, I think, Augustus Caesar. And he went, dude, I want to do it too, bro.
He made the worst
August.
argument.
He made the best month. That's my month.
That's my one.
Right? High five. Gsh, August babies? Gsh,
That's my mom.
August babies?
September baby.
September babies? Shh, we still love you.
January 8th, 2000.
October.
We still love you.
It's
July.
July. August.
So it got shifted down again. Those emperors, crazy people. All right.
How about June?
June was named after the Roman god king Juno, I think. Yeah. All right. What about 20?
Let's go.
Miss Juno's
20?
What? You skipped like 19.
I know.
Quintagon.
Twentygon. You know what? You're not wrong. Twentygon. That's totally legit. Like, if you have no idea what the word is, just put the number hyphen gone, and you're done. And be gone, because if you're, yeah,
Couldn't we just put Joggers? Then?
you can.
Ninagon.
You can, which is why his Ninagon is not wrong. You could totally do that if you didn't feel like writing Ninagon.
Can we put Eightagon?
You could. You could put Tuagon
Can
if
we
you.
put Threagon?
Yes.
Let's put Stopagon.
No.
No, it's
Or the 8.
No, you have to write 8. It has to be a number.
Maybe not, because maybe they don't know what.
The
Onagon?
stop sign originated from Octagon, not
I
backward.
think
Really?
that it's called an icosagon.
I knew it was a C. They're in there.
Yeah, I know there's a scene there too. Only because I know a 20-sided, 3-sided figure is an icosahedron, and so I'm borrowing a word part. Double check it on Google for me, please, after lecture, okay? And let me know.
Got you.
All right, so what if I wanted a 47-sided,
47 go.
47 gun? I want a 47-sided polygon. This thing is a 47 gun. Because I can't think that many numbers.
What if it's a circle? It'd be infinity gun?
Ah.
Infinigun?
Ooh,
Infinagon. I like that. Infinagon. I like that word. You know what? Let's do this thought experiment. Let's play with this. Imagine the triangle. You see the triangle? And the quadrilateral. And the pentagon. And the hexagon. Now imagine the heptagon. And the octagon. And the nonagon. And you see how we're getting a little rounder? Now keep adding sides in your mind. And keep going till you just can't imagine any more sides.
Circle and Infinagon.
Yeah, that shape becomes a circle. Now, a circle is not an infinagon because, because if we're going by those word parts, that gon means that it has a straight side. And there's nothing straight about a circle. A round.
International Women's Day.
Infinite point?
Infinite point. So, we'll come back to the circle very soon. But this concept of the infinagon almost being a circle is actually really, really powerful in mathematics. And I'm very glad that you went there. Thank you.
Thank you, Ryan.
Thank
What?
you.
Thank you.
What?
For what?
You came up with infinigun.
Yeah, the infinagon.
I need to make that my word.
Your word. Infinagon trigonometric. We're just going to make this thing longer and longer. All right. This allows us to talk about the polygon angle sum. And this is for the interior angles. Notice how we didn't make us, we weren't specific. When we're not specific, we typically mean the interior angles. All right. So here's our friend a quadrilateral. Oh my God. And we have 4 angles. I don't know their measures, but they're not equal to each other. Here's the formula. It says, take n, which will be the number of sides from up here. N for number. Subtract 2 from it, and then multiply it by 180.
Hold up.
Oh, shit.
0. I don't know.
So the big question is
Wait, what was N again?
the number of sides,
Okay, so
which this allows us now to deal with any number-sided polygon figure.
So it gives you the total, right?
It's going to give us the total of the angle measures if we were to add up all the angles inside.
Yeah.
Before we had to manually add them up, right? Like 40 plus 20 plus 100 plus, right? And it took forever.
That's-
Imagine doing that 150 times if I gave you 150 again.
Too much work.
Yeah, way too much work. This, no work necessary, like 2 steps, right? So, the question that we can answer is, what is the interior angle sum of, give me a number.
2. Number.
Dude, jinx, man.
69 again.
6, okay, let's combine those 2 numbers and do a 269 agon.
Yeah.
That's weird.
That was awesome. All right, so what do I do?
460. I know. 48,060.
How did you do that?
I like calculator.
Okay, but what did you put in the calculator?
Was like calculator.
So we do that now?
This?
Yeah.
So you typed in 269 minus 2. You put that in the parentheses, and then you did times 180?
Yes.
All right. Everyone else, you should have calculators nearby, hopefully. You ain't got one? Go get one or pull out your calculator app. Calculator app? Your calculator app is charging. Okay. I has no calculator to give. Oh, look, there's an extra one being passed down. Our queen and savior.
Gracias, Savior.
The nada says the thing.
The nada,
Peasant.
Ev-
peasant.
Eveline is like. I'm trying
I'm
to think.
nothing.
I'll find the root of your name so that we can see what your name means.
Yes, of a nine.
All right. So what was the number again? I got distracted.
No, you're.
48,060.
48,060.
No, zero.
060.
Yeah. It's
Yay, degrees.
I said it right, but she wrote it.
But I wrote it wrong.
That's the interior angle sum for the 269 again.
Yes. Which is fantastic, right?
I guess, yeah.
Yeah, you're like, I have no idea why we're going to do this. This is so weird. We're going to see why really soon when we start calculating calculating areas and stuff. Maybe. Maybe.
Such language, sir.
I'm sorry.
I couldn't say it right. I'm trying to like read
All right.
this at the same time.
I need a new page.
What is what list?
What is the interior angle sum?
The,
Of a 269
269 agon.
question mark.
we have to like solve it or what?
Yeah, you put it in that little formula that you were just given. All right. This lets us go on to our next topic, which is to talk about regular polygons. A definition for you. A regular polygon is going to be a convex polygon that is, what is convex? The interior angles, they're all smaller than 180. All right, this convex polygon is super special. On top of the fact that its angle measures are all less than 180, this polygon is both equilateral and equiangular. What does equilateral mean?
All sides are equal, no?
All sides are equal. What does equiangular mean?
Angles are all equal.
All angles are equal. So this thing is equal.
Wouldn't that be an equilateral triangle?
Like an equilateral triangle would be a regular triangle. Awesome. This allows us to do stuff like this. Find the measure of an interior angle of a regular polygon. Regular, how many sides? Something
3.
more than 2. 3?
8.
6.
8,
9.
6, 3, 6, 8, 9. Gone.
What does that say?
Interior. Find the measure of an interior angle of a regular 3,689 agon.
What?
I took all the numbers they gave me and I matched them together.
Better than a circle, yeah.
Oh, so those are like 3 and 6 and
3,000. Yeah, I put them all together. They said 3, 6, 8, 9, and so I just wrote one after another, and it turned into 3,689.
Oh.
Yeah.
I
oh,
was like, I don't remember seeing it.
that's gonna be hard.
It seems like it's going to be hard because this number's really big. It's as easy as 2 steps. You ready?
Okay.
Step number 1, find the angle sum. We have a formula for it, don't we?
Yes.
So let's fill that in. What is the value of n?
The number.
Yeah, this number.
Yeah.
3,689. All right, plug it into our calculator.
663,660.
663.
660.
660 degrees. And I have a comma in here somewhere. All right, so it's a really big number. All right, second thing we need to do is we need to find the single angle.
Oh, let me just divide it, right?
Why is it divided?
Because that's
Because it's a huge number. No,
yeah,
I'm kidding.
no, because that's the total number. So if we want to find the angle of 1, then we divide it by how many angles there are.
Oh, yay.
Exactly, because all of these angles, how all 3,689 of them because they are all the exact same measure, whatever that measure is, I added it to itself that many times to give me this number. And so to figure out how much each one is, I divide it.
Isn't it like
So
the
I'm doing.
average or something like that?
It could be related to. It's not strictly an average, so I don't want to use that word. Yeah. So we're going to find the single angle by dividing by n. Remember, n is the number of
So you divide by
sides,
the 3, 6, 8, 9.
which is the number of angles, and so we're going to take this number. I was nodding, by the way, in case you didn't see. That number, I'm going to divide it by 3,689, and when I'm done, I end up with
179.902.
Yeah, 179.
confirm. Really close to 180. Now remember, convex polygons, those angle sums can't go to 180. They'll never be 180. They're just going to get really darn close the more sides we add. This idea right here leads us to our very next formula, which is the formula to find a single interior angle of a regular polygon. I should write formula somewhere. I'll do that right now. Formula.
What?
Here's the formula, which in symbols does exactly what we just did. Here's our symbol for the measure of some unknown angle, theta. Back to thetas. Here's our formula for the interior angle sum of any n-sided polygon. Take that and divide it by the number of sides that we had, and that gives you the measure of a single interior angle of a regular polygon of that many
I don't even
sides.
know what a theta is.
Theta is just a variable that we use to represent, hey, I don't know what measure this angle is.
Theta's x for an angle.
Yeah, basically. It's just a it's the general variable that we use for angles. Okay?
So we're plugging in what number?
Into theta, if we're in here,
Fraction.
the n would be whatever number of sides we were given. And since right now it's a formula, we don't have any numbers. But once we use it, which we'll see on the next one, we can start plugging things in. So here's our next example. How many licks does it take to get to the center of a Tootsie Roll? Tootsie Pop? No.
This way doesn't do that.
Did he?
Yeah. But then he forgot.
But then he forgot the number. Get a clicker. Click, click, click. All right. How many sides does a regular polygon have if if a single interior angle measures, someone please give me an angle measure.
60!
69.
2.
I heard 2 and 60.
Serious?
I changed it. I was
63 minutes.
Let's do 62 degrees. That's 6 and that's 2 added together.
I got 62.
Oh, man.
7.
All right. We're going to use our formula here because we're given an angle measure. So we're going to plop it into here. So I'm going to rewrite my formula. The measure of the angle is equal to n minus 2, the number of sides minus 2 divided by, or times 180 divided by n. Now our angle measure is 62, so I'm going to make that substitution right here. I'm going to leave everything else the same. And now this becomes a solve for n kind of deal.
We can distribute the 180.
We can. That's a valid thing to do. So,
Wait, wouldn't it be easier to get rid of the fraction?
yeah, it could be easier to get rid of the fraction. Do you want to do that before we do the distribution?
No.
Yes.
Okay. How do I get rid of the fraction?
Divide the whole thing by n.
No, Miss,
Multiply
better.
the whole thing by n in order to cancel the division by n.
Wait,
Yes.
you just
Since it's being divided by n, we want to use the opposite of division, which is multiplication. So I need to divide this side over here by n, and that will get rid of the n over here on the right-hand side. Because 62 is the measure of the angle, not the number of sides. Now we can do that distribution that you were talking about.
180
180n minus
360.
No.
360. 180 times 2 is 360. Double check in your calculator.
Oh yeah.
Now what?
Subtract.
Minus 180.
He wants to subtract 180n. Totally legitimate thing to do.
Yeah.
What I do to one side, I have to do to the other side. I'm going to make sure to line up my variables.
Negative 180.
That counts as here. He said negative 118 n equals negative 360. How do I get n by itself?
Divide
Divide by
180.
118, negative 118. Okay, when I do the division, negative 360 divided by negative 118 is?
62. Round to show.
Okay. I was like, really?
Jesus.
He's handing it to me saying that it's 3.05. Is it going to be negative or positive?
No.
Positive.
Positive. All right. Please don't round these very much. What this tells us is a couple of things. First off, this is supposed to be a number of sides.
You have 3.5 sides.
We have 3.05
Sides.
We've got 3 complete sides and then
Wait.
part of a fourth. You can't do that because that means that your polygon has a hole in it.
It's okay, it's a ship, it's sinking.
It's a sinking polygon. So what this means is that likely this angle measure right here doesn't create a regular polygon. It could create a polygon, but it's not regular.
It created a birdhouse.
Okay, it did something. I don't know what it did. And it's probably not a triangle. If it were a little smaller, it might be a triangle. If it were bigger, it would definitely be a quadrilateral. All right.
So are we gonna?
This where you're going to see when you go to actually do these on the practice assignments and things, you will generate numbers that are whole numbers and that actually make sense for polygons and things. Because they'll have had a huge bunch of people, not myself because I'm borrowing from textbook, to sit down and do these calculations 3 or 4 times to make sure that the numbers they're picking work. And don't do this. But you have the process and that's what's important. We have one last topic to discuss before we are done. And it is a very small topic.
How small?
Like
Small like the last
like
time you said it
6
was small, it
lines.
was really small, or?
No, like small. All right, so this allows us to talk about the exterior angles of a polygon.
Wow.
Sometimes.
Really?
Like,
All right, so draw yourself your favorite polygon.
What's a polygon?
Any straight-sided shape that closes.
Okay, why is your line like A?
Yeah, look, I drew one line all weird. Do that on yours.
So Harry, no.
Yeah, you can have this one.
Do that on yours.
Do that on yours. This angle right here is the exterior angle to this one.
Do I need to make it all twig like that?
You are welcome to make it all twig. This is the exterior angle for and we saw this back when we were doing triangles, didn't we? Talked about the exterior angle
yes.
theorem? Yeah. The thing to know is that these exterior angles are supplementary to their interior pair. The one that they're next to, the one that they're paired up with. Okay? Which means when you add their measures, you're going to get,
180.
yeah, 180.
Oh, I forgot the vegetable.
Sorry, all right, in there.
Thank you.
All right? Now, I want you to imagine something.
What am I imagining?
This. Check it out. So if you extend those sides, and you create a whole bunch of exterior angles over here.
Looks like one of those biohazard things.
Yeah, it looks like a biohazard syndrome when you've got this. But imagine this were an iPad, right? Or a phone. And I could zoom out. I totally can't do it because this is an actual sheet of paper. But imagine, right? I'm zooming out. But as I'm zooming out, these lines are continuing to grow so you can always see them. Okay? So zoom out. Zoom out more. Keep zooming out. Are you zooming out more?
Yes.
You're zooming out, zooming out, zooming out until that triangle turned into a dot and you end up with something that looks like this.
Oh, yes, yes.
Yeah? What's this angle measure right there?
I was
Two.
thinking of the,
One full rotation around a circle is
60.
360 degrees. And so our last concept for today is going to be the exterior angle sum.
Oh, it's not 6
Notice, if I add this angle to this exterior angle to this exterior angle, you got that just by zooming out and getting to this, didn't you? So it doesn't matter how many sides or how many angles our polygon has, if you're being asked for the exterior sum, always 360. Because you can zoom it out and zoom it out until it turns into this dot and have everything all together. Right, when we come back for the next lecture, we'll work on these a little bit more, give you some more examples and some more algebra practice in finding angle sums. Thank you very much.